Hello. So today we are going to take a look at Kotlin's another Kotlin's delegate in the standard library, and today we are going to take a look at notNull. And so notNull is just one of the delegates that are available for you to use in Kotlin's std library, standard library here, and usually a property delegate, basically notNull is a property delegate for a read-write property with the notNull value that is initialized not during object construction time but at a later time. So it's for a property that should be notNull, but it's initialized not during the construction time of the object but at a later time. And so this would mean that trying to read the property before the initial value has been assigned results in an exception. So basically the property delegate will take care of throwing this exception if we try to access the property before it's initialized. Now, properties that are declared as having a notNull type, usually without this notNull delegate, properties that are declared as having notNull type must be initialized in the constructor. But sometimes this is not convenient. So for example, we may have properties that are initialized through dependency injection, or for example, in a unit test, we may want to initialize the value only in the setup method of the unit test, and so not at the construction time. And so this is where this notNull delegate comes in. You probably, like from this definition, realize that this is very similar to what late init does. We'll take a look later on at the difference between the two. Now, this property delegate, just like any other property delegate, it can be used in all places where delegates can be used. So as a class property, it can be used as a local property inside functions. It can be used also as top-level properties. As a top-level property, which means basically not inside a class or a function, so something like this here. Now let's take a look at the first example. So I just have this class X that has this property Z that is of int type, and this property uses notNull delegate. So we have by notNull, right? And so in our main function here, we create so that we can run it. Let's remove it for this one. Yeah, so we initialize x1, which is this class, and then we can, if we try to print it before initializing it, so here we haven't initialized the z value yet, right? Because we are saying it's by notNull. It can be initialized after construction, so we construct x and we haven't initialized it yet. So let's run this and see what happens. So you can see it fails with a nillegal state exception saying that property z should be initialized before get. And doing x1.z here amounts to calling get, which goes in and calls the get function, the get value function of the notNull delegate. And so it fails if we access it before it's initialized. It fails with this illegal state exception. Now, if we initialize it and then print, and so we then access it here, so this will call get, and this here would call set value function of the delegate, so it will set its value to 10, so it will initialize it. So if we print this, now we don't get the exception and we get the right value, right? And so you can see why it's useful. It's because it will throw if we use the value before it's initialized. Now, one thing to note here is, so if I, let's say, here the type is not, this made us like avoid making this nullable, and so having to check every time with the question mark dot. And so if once we use the by notNull, if you come here and try to do this, it's unnecessary because the receiver here is the receiver of this question mark dot plus is notNull, right? Because we didn't mark it as nullable here, right? Okay, so now let's take a look at at the other example where it can be used. So it can be used as a local property, so inside a function. So for example, here I have some function, I have some value s that is of type long, and it uses notNull delegate. And similar thing, we can initialize it and then print this value. And if we call print before we initialize it, let's try that, it will throw a similar illegal, sorry, not this one. Let's comment, let's remove this main, and let's enable this main instead that runs this function. Okay, so it fails again because we are trying to access property s, but it's not initialized yet. And so you can see property s should be initialized before get. And just notice here that it's calling a notNull var get value. Get value is the function that gets called when we access a property that is backed by a delegate. And now if we comment this, it should work fine since we initialized before calling get. That's what happens. Now it can also be used as a top level property. So you can see here, it's like in the file, not in a class or in any function. So we have this var property of type int that is backed by this delegate. And that now in our main, we just initialize it and print it. It should work fine as well. Okay. Now let's see the differences between this and late init. Late init kind of accomplishes a similar thing, but late init is not allowed on properties of primitive types. It can only be used for non-primitive types. So for example, you can't use it on an int or a long or a boolean. So notNull is useful to, and that's where notNull delegates comes in. It's useful to accomplish what late init does, but for primitive types. One thing to mention here is notNull delegates basically creates an extra object for each property. Of course, like this object is small, but if you have lots of properties that use this notNull delegates, it can add up and become significant. So the recommendation is usually to use late init if for properties that are of a non-primitive type. But if the properties of primitive types, you kind of have to use notNull if you don't want to initialize it at construction time. And so here, just to give you an example, if I try to use late init with a primitive type like int, it doesn't compile. It says late init modifier is not allowed on properties of primitive types. So now in this case, since we get this, what we do, just replace late init with by notNull, and it will accomplish a similar goal, right? And it works fine there. However, late init works fine with non-primitive types. So let's say here I have this class thing that just that has this function that prints doing something, and I have this example class where I'm doing a late init on an instance of this thing. So let's just name it thing. And then we have also late init on a list of strings, right? We can also have it on a list of ints, right? So you can see it doesn't work with primitive types themselves, but it can work fine on list of primitive types. And so let's just make sure that this is working. If we run this, it should call do something and it should print do something. Okay, we have a slight problem. Yeah, so there's a, yeah, it does a similar thing to notNull. Here it's failing because we didn't initialize thing. So it's doing the same thing as the delegate, but if we initialize thing to, let's say, anything here, right, it should pass fine. Okay, so it does pass fine. Now if I, let's just comment this for a second again. So we are not initializing it, so it should fail here. So you can see the exception is a little bit different. It says initialized property access exception, late init property has not been initialized. So it's a little bit similar, but it's kind of different. Okay, so now just another thing to mention here is that you can use this delegate on even like function values here. So I have this fn, which is a property that just represents this function, double, that takes in a double and returns a double, and we can use by notNull in that case. We can also use lateInit in the same way. One thing to mention as well is that IntelliJ has a quick fix for what I mentioned here, where you are trying to use a lateInit on a primitive type. So if you tried that, IntelliJ has a quick fix to convert it to use a notNull delegate. So you can see here it's saying lateInit modifier is not allowed on properties of primitive types. Let's switch to presentation mode. And so it's saying lateInit modifier is not allowed on properties of primitive types, and it has this quick fix to convert it to notNull delegate. And if you also do just Alt-Enter, you can see it asks you either to remove the lateInit or to convert it to a notNull delegate. And if we convert it, so this was a property B of type Boolean, which is a primitive type. And so if we convert it, it becomes, it uses the delegate notNull of type Boolean, right? So very simple, very straightforward. Let's just take a look at the code a little bit of this delegate. So this is just a function to create a notNull delegate for you. And if we take a look at the class, it extends read-write property, which means it can work with vars, essentially. And all it does is it has this backing value field that is nullable under the hood, initialize it to null. And then when you call get, which is called get value here, which is called whenever you try to access the property, either if the value is not null, it gets returned, but if it's null, it returns this illegal state exception, the one that we saw when we ran the example earlier. And it says just the property with the property name should be initialized before get. So this is what we saw exactly. And then when you set the value, it just set it normally, just does the default thing. So you can see it's pretty simple. The only difference is like this, if it's null, it throws the illegal state exception, and then it has this package field that behind the scene is nullable. And you can see also get value here returns you type T that is not nullable, because if it's not null, we'll throw instead. And yeah, so that's pretty much it. That's pretty much what I wanted to cover for notNull delegate. Thanks for watching, and see you on the next video. Bye.